Good afternoon, everyone. Hopefully, you can hear me okay. My name is Srikanth Vijayaraghavan. I'm part of NVIDIA, and I manage our global relationship between the two companies for all of our software and solutions business. So I've been with NVIDIA for close to 5 years now. So I gave a talk here a couple of years back in one of the rooms on the other side. It was on generative AI. It was just after ChatGPT became a huge thing. So today the talk has shifted more towards agentic, right? Very quickly, within 18 months, 24 months. So the way the session is built is to kind of give a quick explanation of what it means moving from a chatbot to an agentic era, and then look at what are some of the barriers for enterprises. And what's NVIDIA's perspective? We'll look at that first, how we have tried to solve for it. And then we'll briefly talk about how we have worked with HPE to bring some of the solutions to the market, right? So that's the structure of the presentation. Hopefully it'll make sense as I go through it. And also I want to say that part of this presentation was actually written by agents, believe it or not, and you will see some of that, okay? Okay, so let's ground ourselves, understand the difference, right? Chatbot, very simple, right? We take a model, we feed it a whole bunch of data, make it smart, and then when we need it, we go ask a question so we can get an answer, right? And as more intelligence is needed, you pound it with more data. So basically, it's a simple one-to-one interaction. You ask a question, there is context-aware model that gives you an answer back. So I think this is a great use case. Many of the co-pilots that you get are pretty much a one-to-one interaction, right? Because it's doing some analytics, it's coming back to you with some answers. And there is a lot of innovation happening here, how to make it faster, how to make it more smarter, the response and such. And now, if you look at agentic, there is a big difference because it is not a simple one question, one answer, right? I think we have gotten to a point in technology where we can actually go solve problems. And typically, when you want to solve problems, there is a logic, there is a sequence of things that need to happen, right? Because you're breaking down the problem, just like a math problem. You would break it down, there are multiple steps. There is some level of research involved, some learning involved. Then you are compiling the information. You could reiterate to make the answer better, right? And in most cases, after the first answer comes, the user is usually curious. You want to ask more questions, right? Therefore, the model can go back and bring something back to you. So really, agentic kind of moves into something more important. You can actually solve problems, build more strategic assets for your company. It can be part of your strategy building exercise as well. So it's a little bit more complex than where we were before. If you look at it, the time involved, typically, obviously, it takes a little bit more time. And you were in the previous session that Steve was presenting, and if you have ever seen any of Jensen's keynotes, he talks about test time scaling, because as you go into agentic, there are multiple inferencing applications running at the same time, and they're talking to each other to come up with an answer. So you are actually scaling your inference at test time. So typically what it is doing is that cycle, okay? It's basically creating a plan, it's reasoning with it, it's looking at what kind of data is available. Maybe it's your own enterprise data, maybe it's going out in the web, depending on what you choose, and then it's reiterating. So this is mostly for you to take away. I think you get the slides on, what is the big difference between chatbot to agentic AI as we move into this era. So to understand the barriers, because what you see on the right side is a lot more complex, right? It's not a simple process. And needless to say, there are tons of barriers, right? And I work at NVIDIA, and we experiment and explore a lot with these things, and I can tell you it's not easy. So we can look at the barriers first, and you will see some flavor of AI agents that wrote these slides here. Not completely, some help. So to understand what the barriers are, I wanted to use a hero here, that's trying to do something. And what are some of the typical barriers you see, right, and within an enterprise? So we're using Dr. Sophia here as an example, trying to, being a digital biologist, has a task where she has to cut the budget on drug discovery by so and so dollars, and come up with some answers for their drug discovery. So typically, if you look at it, in most enterprises, a line of business with a reasonable budget would just go and get a server with a GPU. They'll start playing with software, open source, whatever they have access to. But in this case, because we are in a HPE and NVIDIA event, I'm saying, she could have an NVIDIA GPU enabled server from HPE with access to our software. And you could go run and come up with an answer that could help accomplish this drug discovery problem. The barriers come when you think about how you take this and scale it to a production level environment within the enterprise. And a lot of times when you take the answers to your boardroom, it's seen as a risk. And I'll talk about the risks in a second. Rather, it's very innovative, but it comes with a lot of risks, right? So let's understand the risk. And this is a slide that you would see again and again in many places. Antonio shared a version of this as well. These barriers directly contribute to what you're seeing here, right? A lot of people are investing in AI, but not many of them are successful, right? And it's not because the technology is not there, but there are several hurdles that you have to get through. Now, I've tried to put this in a very simple format so that we can understand. So if you look at some of the leaders in the organization, because these guys are constantly being asked about what's your AI plan? What's your agentic AI plan? Do you have a digital workforce plan? Right? This is a question that the boardroom is facing all the time. So each one of them, they have a different set of problems that they're dealing with. So as a security officer, clearly data is central to it. We've been talking about data being important for AI, at the same time where the data resides, and what is the compliance that the data needs to follow. These are very important from a security officer's perspective. So a lot of agents typically are capable of just using many data sources, not just your enterprise data source. You can go out and you can do a comparative study, right? You can go pretty much look at any research that's publicly available. That might be a no-no, if you're a CISO. If you want to go use a tool that is publicly available where you have to upload your data, that's a no-no as well, because you want your data to reside on premise. So there is a lot of complexity when it comes to your data, right? The second pillar that you could think about is what is this going to cost me, right? Because typically I said, okay, test time scaling, you're going to do a lot more inferencing. You're going to need a lot more infrastructure. How do you predict that cost, right? How do you think about how am I going to forecast and build an enterprise plan? So that's always not very clear in the beginning. And the third pillar is really from a CIO's perspective, because now you're talking some new dimension, new kind of software, new kind of problem So you're like, how am I going to manage this? What kind of training is needed? What kind of enablement is needed? What kind of tools are needed? How are we going to lifecycle manage it? All these questions come into picture, right? So these are all real barriers. It's not just these guys want to, be blockers, but these are real problems, right? So we have to fundamentally rethink how to solve these problems a little bit. And of course, NVIDIA spends a lot of time on this because we do a lot of this in-house quite a bit. We have a lot of agents, we have a lot of AI-related tools that we use. But you can summarize, if you want to think about a sound agentic AI platform that an enterprise wants to develop, typically you can summarize this under 6 pillars. This is how we see it internally. And these 6 pillars are called out here. I'll make a brief comment on each one of them. So data, we talked about data. If you think about it, in the current environment, if there is a data breach, it is not just a technical problem anymore. That's a huge business problem these days, right? So it has a huge impact on your business. So having capability of running things on premise, maybe running things in a secluded environment, where you're air gapped, many of these things could come into picture depending on which industry you are in, right? So these are some of the important things that your AI factory should be capable of. They have to be able to provide that, that feature. The infrastructure, a lot of time is actually spent in bringing all of your data resources together. Typically, just using, say for example, I'm just throwing this out, one BU's ERP data and building a prototype might be great, but if you're thinking about building something for the entire enterprise, you want to spend a lot of cycles making sure that the data that you're going to use across all these agents, these digital workers, those are curated first, and they are integrated well to whatever that front-end infrastructure is going to be, right? So a lot of time needs to be spent on making sure these are well integrated. Which models do you use, and how you track them is super important. Because the moment you go into agents, most of the good agentic tools, typically they say, okay, this is my line of thinking. This is how I'm going to do the research. And it allows you to go back and even edit it in some cases. Okay, you can say, no, I don't want you to go there. I don't want you to do this. You're able to do that kind of edits, in your agentic flow. So having tools which gives some user control, having tools that actually gives you excellent observability across the multiple agents becomes very important, okay? So that's something that you want to look for in your tools. So when you go into agentic AI, it is not just a data scientist problem, okay? And Jensen talks about this a lot. It is a team sport. The moment you go into this space, you want your IT team, you want your cybersecurity team, you want your data scientists, you want your lifecycle management team. Everybody needs to be around the table, right? It's a team sport. One person cannot solve for this. So an enterprise has to invest in it as a team, right? We have to understand the scalability and costs of it. So typically you could start small doing a POC, but then how are you going to scale it? Is it going to be a hybrid environment? Is it going to be something turnkey a vendor provides? Are you going to build something on your own? Having that vision of what my cost is going to be to scale this to a production environment is one of the main pillars. And lastly, the lifecycle management, which the IT guys are very interested in. So here really, this is not a one and done. This is not, to use a very crude example, get a software off the shelf that we are used to, an enterprise software that runs great for a year before the next version comes. No, right? So this space is extremely fast. So you have to be able to update your models. You have to be able to train your models over and over again. you have to be able to lifecycle manage the entire process, the AI ops process. So there is investment needed in this area as well. So really, each and every one of these pillars, you have to have investment and a lot of thought put into it to be successful if you want to build a deep research, agentic AI platform. Now, so given those 6 pillars, this is NVIDIA's blueprint of how an agentic AI factory should look like. And I'm not going to explain everything on the next few slides because they said I have to stop at 45 minutes. But I'll try to. Obviously, there is infrastructure. The infrastructure has to be performant. They all have to sing and dance together. Key pieces being, the GPU and the networking. Again, we heard a lot about this today in the keynote. So our infrastructure has to be a good reference architecture that's tested and proven. So that's the first area. So we have tons of work that is done there. NVIDIA certified compute, storage, networking, and everything is out there. The next layer, which is core software layers, if you look at it, this is where NVIDIA has quite a bit of software IP. People don't realize this. Obviously everybody knows NVIDIA makes GPUs, but there are a couple of things which are super important, and I'll repeat this over the rest of the session. A lot of focus is really on inferencing for enterprises. Okay, very rarely you are going to go train and develop your own model, right? You're going to pick up a model or a few models. You will fine-tune it, of course, on an ongoing basis. So inferencing becomes really key. So one area where NVIDIA has invested a lot is what we call NIMs, or inferencing microservices. These are easily deployable models that will allow you to run your inferencing applications. And this is a huge library. Some models are built by us from the ground up. We support most of the open source models, both proprietary as well, and open source models. And we package them, and we make sure they are super performant with the infrastructure that is sitting below, right? And in the process of your lifecycle management, typically, you are taking care of the model. You're, like I said, first you have to decide on a model. You're curating it. You're adding more data. There are many steps you take. So what we call NeMo here is a collection of tools that allows you to do that. So we have put a lot of effort into this. We package this as AI enterprise, and that's what gets the job done for you. It's enterprise grade. It's production quality. We support it. That way you can rest thinking that these are not just open source code that you're pulling out of one of the open source areas. And from a workload perspective, again, we talk about this at our AI factory session. So we have gone from generative to agentic. The next frontier seems to be physical AI, where you also bring a lot of the digital twin simulation, physics, everything into it. So what we have built from the ground up, the infrastructure and all the microservices that have been built, we have kept all these workloads in mind. So these are pretty much built in a way that it will support everything across the board. So the blueprint has been built. It's solid. It's proven. We have it out there for quite some time. And this follows, this solves for the 6 pillars that I was talking about. Now, one thing I want to say here is, if you look at it, there are a couple of gray boxes that you see: security, observability, data characters, and such. So NVIDIA does not build everything, right? So we build the core where we have core competency, which is basically the models, training the models, making sure they are performant, and they are maintained for enterprise grade over a period of time. Some of the other things you could actually get from third party. There are many ISVs who do a fantastic job. Many of them are here today. I think a couple of them were called out in the keynote as well. CrowdStrike, Fortanix, for security, OpsRamp for observability from HPE themselves. So there are many ISVs who do these things very well. Again, these are fully tested and validated with the blueprint. So that's kind of what is summarized in this slide. For outside of the things that NVIDIA provides, we have a huge ecosystem of ISV partners that we make sure that they work really well with our blueprints. Right? So we spend a lot of time. We have a program called Inception Partners, about 18,000 ISVs are in it. And then there's a smaller subset in what we call NPN. These are a little bit more mature ISVs, and some of them who have a very good go-to-market built with us. Okay, I'm going to shift gears now and talk a little bit about how we work with HPE to bring some of this to market. Because as we all know, a blueprint is just a blueprint. Somebody has to take it and build a product out of it, right? So we have the blueprint. We work very closely with HPE. And HPE has an excellent portfolio of AI factories. And I think this is a great slide. I've borrowed some of the slides from my colleagues. If you look at, like I said, most enterprises are going to be in this side, right? Unless you are a model builder, or you are building something, you are a government, or you are a drug discovery companies and such, where you have a need to develop your own model from the ground up. Most of them is going to be on this side, right? So HPE has many flavors of AI factories. All of them follow our what I showed as a blueprint in the previous slide. So quick rundown: turnkey private cloud AI, private cloud AI is the turnkey AI factory. You might have heard about this. We launched this last year at Discover Vegas. So it's been selling for about a year. It's been a fantastic 1 year we have had with the product. And Antonio talked about this as well this morning on Gen 2. So what is the big deal about turnkey? So turnkey is on the software side. Of course, the hardware is all the reference architecture. On the software side, we make a lot of decisions for you. So we say, we will bring the NIMs, we'll bring the AI ops tools, that most commonly you would use, a tool chain that you would need to put something together. And some of these decisions are made for you. The control plane is already fixed. So when you buy a turnkey AI factory, on day one, you are basically ready to actually try some real AI applications, right? And then there are customers. It really depends on where you are in the journey. If you have gone a little bit farther, then you would say, I don't want you to make all the decisions for me because I have some preference. You could have already played or made an investment in an MLOps environment, for example. You could have already made in an orchestration environment. In those cases, HPE also offers AI factory for scale and sovereign, which is more Lego block. There are some non-negotiable blocks, but many others are, we give the freedom to the customer to bring their own tools. Okay, so quick glance on both of these, how it looks. Private cloud AI, there are a few flavors. There is a very small single node developer unit, which is great for starting your journey, building your dream, if you will, for a POC. And then from there, you can move into different sizes of configurations from a hardware perspective. The software above, though, doesn't change at all. Okay, no matter what you get, from a small to all the way up to a large and extra large configuration, you get the exact same software. And if you're a GreenLake customer, you are actually much ahead because the control plane of GreenLake, Morpheus, is the same control plane that we use for private cloud AI. Okay. On the left, the software stack is fixed, like I said. You can use it out of the box. We also do a lot of work. I showed you the blueprint of the reference architecture. Then we build blueprints for use cases as well. Okay, NVIDIA builds blueprints. For example, there is a RAG blueprint if you want to build a RAG application. There is an agentic AI blueprint. We have a data flywheel blueprint, which basically allows you to curate your data and prep your data. Many of these blueprints are already tested, validated, natively available on top of private cloud AI. So in the keynote, again, Antonio talked about IQ. It's AIQ, but we just call it IQ. So this is basically an agentic AI framework blueprint, which is readily available on top of PCAI. Okay. Quick slide. I'm not going to go into the details, but we are in the second generation of this product. You could start with as small as 4 GPUs, and you can go all the way up to 64. Okay, you can go up to 4 racks, and you have many, many GPUs and build a huge cluster, depending on where you are in your journey. In the second generation, our RTX 6000 GPUs, which is, we call it a universal GPU, because it can obviously do AI workloads, but it is also great for any kind of virtualization workloads. It is great for digital simulation workloads, 3D workloads. So the picture that you saw, where I said agentic AI, physical AI, RTX 6000 is a great universal GPU for running all of those workloads, which is available in the second generation of PCAI as of today. Okay. So the other end of the spectrum, which is basically here, is we are saying you as a customer, you are a little bit ahead in your journey, and you are not looking for something that is coming off the shelf. So in this case, it looks and feels very similar. The control plane is exactly the same. You get a lot more variety in hardware, and you also have the capacity to decide what is the size of your cluster. Typically, the customers that are buying this are buying 64 and up, right? At least minimum of 64 GPUs and up, because they have gone through the POC, right? So all of these capabilities are available. You see on the right, it's very similar to the NVIDIA picture that I was showing you. Here is where all the ISVs come into picture. You can get a third-party observability ISV from that validated list that we showed. Same thing for security. All of those work on top of the platform. There is quite a bit of work done here with NVIDIA software as well. Let me just build the whole thing out. Okay. So from the blueprint that I showed, a lot of the NVIDIA software is part of this AI factory as well. And when I say it is part of this AI factory, it means all of these are tested, validated, integrated, right? And so how you deploy your cluster, how you manage and orchestrate, with all of your GPUs in the Kubernetes environment. So we have a tool called Run AI, which does that. Of course, on the top, all of the NIMs and the models and the inferencing microservices. Everything is also integrated in a factory that is at scale. So, for example, Antonio talked about, I think he talked about, it was in the PR. So at the Grenoble Center in HPE, so we will have one of our scalable AI factories available for customers to come in and try their use cases, right? So it's going to be built on next generation GPUs. RTX is part of it. P300 is part of it. So it's going to be a forward-looking, scalable AI factory where you can come and do some of your work. Okay, so I want to spend a few minutes. I know I mentioned these names a lot, but I want to double-click just on this one slide. That way you understand what it means when I say a blueprint or when I say NIMs, what exactly that means. Because we call this, full stack in NVIDIA, and we talk about this a lot. Even if you have a H100 GPU today, right, which has been out there for 2-3 years now, you can still continue to get somewhere between 30 to 40% performance improvement on every one of our software updates. That's the beauty of building everything full stack, because obviously there's infrastructure layer. If we cannot change the GPU anymore, we are continuing to always optimize the stack, the rest of the stack from a software perspective. So we have seen customers, continuing to see performance improvement, because of that. But if you look at how we build these things, outside of the infrastructure, the first thing we build is the inferencing microservices. Now here, it could be very generic, or it could be something very specific to a vertical industry or a use case, depending on which model and how it has been optimized. A good example is we have a model called Cosmos, which is a great reasoning model. It's a reasoning model that's very popular in the physical AI side of the house. So if you're doing a digital twin example, if you're doing something like a synthetic data generation type example, use case, then that model will be a great fit, and there is a NIM for it, right? So if you are doing a text-based environment, we have a NIM pretty much for all the GPT models, many of the open AI models. You could use any of those. Similarly, if you're doing something in the video analytics side, if you look at video analytics, it's a great one to look at the transition. In the generative AI days, you would reactively look at the video, right? And you would come and do some analytics on it, right? Anytime there is an anomaly, you can find out. In the agentic AI side of it, we have what we call video large language models, right? VLMs, you might have heard of it. So we have video search and summarization capability. So many media companies do this because sports is going all over the world all the time. So you could go and say, hey, show me the 5 plays where a goal was scored in the last 5 minutes. You can get it. So video search and summarization, things like that, where people want to consume content on demand. Right? It's one example, but there are many examples. So first thing we do is we build a NIM for pretty much all of those things. Okay, and these NIMs are continuously updated, lifecycle management that I talked about. So if you look at the top, the curator is basically continuously looking at the data, making sure that the data we feed to train these models are good. In many cases, in our own model, Nemotron models, we even make the data public. You get access to the data that we use to train as well, right? These are not controlled environments. Or you can customize your model where you're fine-tuning it. You can evaluate a model, right? If you say, hey, I could be using GPT, or I could be using Meta's models or Llama or something else. I want to see which one is best for me. You can do that, right? So you can go evaluate your model, the size. Again, you want to use an 8B model. Do you want to use a 70B model? It depends on what kind of response you want. So these tools allow you to go evaluate some of those capabilities. Guardrails is super important. We talked about hallucination in the previous session. So guardrails allow you, to put in some rules, right? So we have internal tools from HR. You don't want to people asking, very confidential questions. Say for example about wages or things like that. So you want to put guardrails saying what is allowed, what is not allowed. That's one way of thinking about it. So we go through this cycle ourselves, right? Drinking your own champagne, or somebody said eating your own biscuit in another session, whatever that is. But we use all these tools that we put in the blueprints ourselves quite a bit, okay? Once we do that, then on top, we try to bring it all together, the AI tool chains. So what do I mean by that? So typically, you need to build a Jupyter notebook or something, where you're bringing, this is, okay, my Kubernetes environment is so and so, this is how I'm going to stitch my AI tools, and this is how I'm going to observe it, and this is how I'm going to create a dashboard. There is a bunch of tools coming together to actually create a use case. That's what an actual blueprint is. It is not a finished product. It is one opinionated version of how you would do a use case. It's a starting point. So we provide all these blueprints. Then many of our ISV partners take those blueprints and they build more fully customized apps on top of it and bring to market. Now, the best way to think about it is there is always a build versus buy model when it comes to AI. So if your need is to go build something that is very specific to your company, you can take the blueprint and you can build your own. If you say, I have a use case and I need somebody to provide me a tool for that, you can do that as well. You go pick one of the ISVs from the logo garden that we publish as part of our platform, okay? Let me see, where am I? Okay, we have time. Okay, so I covered this quite a bit in detail, but this is kind of how we build all of our stuff. Some key things that we use in our blueprints are the retriever is a very important application for your RAG, because typically this is where you are trying to get data from your data sources across your enterprise. So you want to have a really good RAG environment, a good retriever environment. And the reasoning model, you have multiple choices, many choices across in the market. But we also put out something called Nemotron. Like I said, the model is out there, it's open source. The data we use to train it is also open source, it's available for everybody, okay? And then all the agents that we give us blueprints sit on top of that. Okay, so why did I go through this? So I want to come back to the barriers and spend some time here. So obviously there's a lot of technology involved. But if you, a quick recap of what I was trying to say is, agentic AI flow is very complex. There are barriers across security, across information technology, across your finances. These are typical barriers that gets put up in a typical enterprise. So what we have built allows you to change that narrative. And we make the narrative change in a certain way, right? So as a CISO, there are opportunities here where, basically your data, which is proprietary, can never leave the premise. You can do that work on premise. All these tools are available on premise. Antonio talked about air-gapped this morning. So we support air-gapped environments. All these tools can run completely detached from the internet, right? So there is a way to do that. So if data residency and data governance is important to you, there is a way to do that. That problem is solved, right, to some extent. For the CFO, I showed you the portfolio, right? There is a developer system, and then it can scale all the way to 4 racks. So the best way to think about it is get a POC, get it done with the developer unit, and when you're ready to scale, you can move across the board. So you kind of know what to expect on what's coming in a turnkey environment. Once you grow out of the turnkey environment, maybe you're ready for doing and building something at scale. But the point is, we have right-sized it, saying depending on which stage of your journey you are on, you can pick the right platform and work on it, right? And then finally, on the information technology perspective, so you don't need an army of data scientists. It was probably 100% true even 2 years back, because it was still not an easy task. Most of it was building things from the ground up. So today it has gotten to a maturity level where most of us will be able to pick up a blueprint and can do some damage with it, right? So with some training and enablement, I think you can easily support some of these agentic AI workflows, one part of it. The second part of it is the tools are really mature. All of these are supported very well. You get enterprise support. Even NVIDIA, most of our stuff used to be in NGC, which is our open source repository. But we have taken a good portion of that and we have made them enterprise ready, right? So we do all the security testing and everything, and we actually package it and we release it twice a year. So the tools have gotten to a good place where you can actually lifecycle manage it. So it has gotten pretty mature. So the 3 barriers that we talked about, there are ways to actually bring it down. But really, how you get to prompt to production is really this, right? I know many of you get asked about, what are we doing about agentic AI? I think the key is, and probably I've heard this many, many times, there are lots of use cases. I mean, there are like millions of use cases. Is everything relevant for agentic AI? No, right? So the first thing to do is find that complex use case that is relevant for agentic AI, and start a POC. The first thing to do is to get on a developer unit, maybe a single unit, because all the software environment is exactly the same, whether you are on a developer or you are on a 4-rack environment. Do a POC, see the returns on it, and then think about from there, how do I go to a production path, right? But everything above the infrastructure, the software layers are all pretty consistent in the reference architecture. They are constant at this time. So with this, I will conclude my speech, and if we have any questions, I'll take them.